get more energy.
No, you won't. I gave you a break earlier and I came back with him sleeping on the ground. What?
What time is the machine?
In half an hour. Yeah, so just hang on for half an hour and then you can go home. Be strong. Right, next lesson is called Modulus. Fuang, do you want to get coffee?
No, I hate coffee.
Just can't win.
I want to.
Nobody asked what you think. Right.
What did you say this? O? Not O? W? W O.
So W. W.
No, it's not.
Wuku?
No, it's not.
Guys. Omar, put the phone away.
Originally from Chinese.
Yeah, I told you it's definitely from China.
You can teach them after class, okay? Bye, Saul. Put the phone down or I'll take it. Thank you. Now, modulus function. So in maths, we have this special function called the modulus, also called the absolute of a function, and you write it like this.
2 lines.
Yes. And the meaning is quite simple. If the x is positive, then it does absolutely nothing and gives you back x. If the x is negative, then you get back the positive of it. So, examples. Absolute of 2 equals 2, absolute of 3 equals 3, absolute of minus 4 equals 4, absolute of 0 equals 0, and so on. So basically we can also say absolute is always positive or 0. It is not negative.
What's a real life example of this?
But we can use this in physics.
Like?
There are some formulas that have absolute in them. That you only care about absolute differences rather than the positive or negative differences.
Like for example changing temperature.
Yes, I suppose so. Okay, so this is the definition of modulus.
I made a discovery.
This better be good.
All the chairs here in the bottom in the middle
Yeah.
have a circle.
Yeah.
No.
What?
Well, I was laying down on the
How
ground.
is it
Why does this chair have a circle? Oh, this one has it too.
Maybe it's for the same reason a microwave has a vent at the back.
But no, it's not a hole. It's just a circle at the back.
Maybe it's when they're making the plastic, it's where the machine disconnects. You know what? I don't care. Yeah. Continuing. So, how can we deal with modulus functions algebraically? So, for example, how can we cancel a modulus function? Well, there is one way to easily cancel it. Let me show you why. If you have a number squared, you don't actually care if it's positive or negative. For example, minus 2 squared is the same as 2 squared. They both make 4. So this does not care about the sign. Now, that's good because that means the modulus of x squared and not the modulus of x squared is the same thing. This will make it positive. This could be positive or negative, but we don't care because the number will be the same. So in other words, the way we can get rid of a modulus is by squaring. So if you have, for example, the modulus of x is equal to 3, you can square that and get modulus of x squared equals 9, or just x squared equals 9. So what does x equal? Plus or minus 3, which of course makes sense. So this is how we can cancel a modulus, by squaring. Please make note of that. Faisal. Give a teacher a break, please. Have mercy on me. Alright. Got that, guys? So next, we want to have a look at some simple examples to solve. So let me just zoom in here. Right, let's have a look at this one here. Can you write this one down? We'll do this one. To what? This? Come on. No, yeah, you don't know. You have to be quicker than that now. Write this one down and then I'll do it. Faisal, remember the no touching boys rule, please. Touch is bad. No touching yourself in class, Faisal, thank you. Okay, do you write that down? So, let's have a look at solving this one. What was it? -3 absolute.
-4.
Yeah. Oh, minus 4 absolute. X minus 3 equals minus 16. So we divide by -4 and we get 4. And then we square. So we get x squared minus 6x plus 9 equals 16. X squared minus 6x plus 9 minus 16. What's that? X squared minus 6 minus 7, isn't it? And the roots are -7 and plus 1. So the answer is x equals 7 or -1. Now I'm going to show you another way to do it, so it could very well be that way. There is a second way to do it. The second way to do it.
This is the form of triangle.
No.
Ignore the negative.
Which negative?
-1.
No.
But you said it can only be positive.
Correct. What's -1 minus 3?
Oh, and that's
Yeah. Okay. Now there is another way to do it. What you could do, just look here actually. You get absolute of x minus 3 equals 4. And then instead of squaring, you can say, well, that means x minus 3 has to be a +4 or a -4. Because only the absolute of plus or minus 4 could make 4. So that means x has to be 3 plus or minus 4, which is 7 or -1.
Oh.
There's another way to do it, perfectly fine.
That's easy.
Yeah. Yes, now that doesn't always work, but it does here. Okay, can we go to the next one here? So next, let's look at how we can make a graph here. Can you write this one down?
This one?
2a. Oh, I'm going to need a strong Irish coffee after this class. Double whiskey, please. Right, let's have a look at this. Does anybody know the shape of this function, the modulus function? Does anyone know the shape of the graph? It's like a line, but there's more to it than just a line. Well, yes, that's it. This makes a V-shaped graph. Yeah, because when x is positive, you just get the same thing. So like if this is 1, then here is 1. And if this is 2, then here it's 2. But also if it's -1, it's 1. And if it's -2, it's 2. So that's why you get the V shape. Yeah? Now, there are two ways you can make the graph. I will show you both ways. The first way, you make the graph the same way you make any graph, by finding the roots and the intercepts.
Reflect it only the half that is on the negative side.
Please, be quiet, thank you. What was the graph I wanted to draw? Y equals
Minus 4, absolute.
absolute.
No, no.
Minus 4.
Minus 4 and then absolute. X minus b.
Plus
Plus
60.
Right. So think about any old graph. You should find out where the x and the y intercepts are. So let's do the y-intercept first. How do you find where the y-intercept is? Let x equals 0. So then we got y equals 16 minus 12. So 4.
How did you get
Then.
or you multiply?
Yeah, here. Faisal, be quiet. Yeah, here. 0 minus 3. What is 0 minus 3? Absolute of minus 3? 3. Multiplied by minus 4? Right. How do we find the x values? Y equals 0. So you get this. Do we know how to solve this? We do. In fact, it is literally the same. I did that on purpose. So it's the same. So we already know how to solve it. This is the same. And what answers did we get here for x? So if I draw the graph, it has a root here at minus 1 and here at 7. And where's the y-intercept? At 4. Now, finally, because this is a negative, is it a U, a hill shape, like concave, convex? Is it like a U or a V shape? You know, is it going to be V? Yeah, but it's still the same principle. Is it a V shape or like a mountain shape? It should be a mountain shape because it's supposed to be like this. So the graph goes up and down. And finally, we want this point on the graph too in the exam. How do we find this point? Well, a bit like, a bit like completing the square. Think about this. This here is always positive, yes? But we multiply it by a negative, so this part here in total is always negative. Positive by negative is negative. So if I want to make y maximum, should I make this bigger or smaller in total? Yeah, I should try and make it 0 actually, because then, so 16 is the biggest, and when does that happen? When x is 3. Now this should remind you a lot of completing the square, where you had a x minus b squared plus c. Where was the maximum here? When x is b and y will be c. And it's not an accident, because the modulus and the square have a similar role of making the thing positive. So we can have the maximum here as well. They need all of these points in the exam for full marks. They want the roots, the intercept, and the vertex. Now I said there are 2 ways to do this one. I'll show you the second way now in a moment. You probably should write this down. So you need to find, I'll put it here, this is for the y, then here this is for finding the x, and then you also have to find the vertex, and then also the shape. We're nearly finished. A few more minutes, then you can go home and sleep. Continue? Yep. Right, next. So, here's another interesting way to do it. Here is the graph. Actually, I'll make it nice and big. Let's say y equals fx, and fx is the absolute, the modulus function. So what graph do we get here? We get a nice V-shaped graph like this. Now, can you please read out the example I had a moment ago? What was it? Y equals...
Minus 4.
Yep.
Absolute.
Yep.
X minus 3 plus 16.
Which is y equals minus 4f of x minus 3 plus 16, where we're calling f the absolute. In other words, I can change this in a transformation problem.
Yeah, that was it.
That's what you were thinking. So what does the minus 4 do? Well, what does the 4 do? The 4 will...
And make it bigger.
The 4 will make it like this, and then
No.
down like this. The vertex and the roots are still at the origin, though. The minus 3,
Yes, it's right.
so now it's here at 3,
It's 16 off.
and 16 up. So now it's up here, and this is the point 3, 16. Yeah, and you might think, you might think this method is easier to do, and it is easier to do. But the problem with this method is, I think it's kind of difficult to see. Well, you could actually still see. I drew that very ugly, by the way, because this should really be more like this. But anyways, it doesn't matter. This method, it works fine in the exam as long as they don't ask for the roots and the intercept. If they just want you to do a rough sketch, you can do it like this. So if the question says to draw it with the vertex, then you're happy with this method. But if the question said to draw it and to show the roots, the intercept, and the vertex, you have to do it this way. But this is still a good method. Yeah. Okay, continuing now. So, how can we solve it with inequalities? Well, I think the easiest way to do it again is with squaring. So, for example, let's say I gave you some problem like something simple like twice absolute x minus 1 less than or equal to 4, for example. Well, what should I do first here, do you think?
Divide by 2.
Yeah, divide by 2,
Minus square.
and then I get this, and then square. So I get x squared minus 2x plus 1 less than or equal to 4. So x squared minus 2x minus 3 less than or equal to 0. This is x minus 3 and plus 1. So the roots are at minus 1 and 3. And do I want above or below? This part here, because it's less than 0. So that means x should be between minus 1 and 3. You don't like this method. There are other ways to do it, maybe even the way you learnt in high school.
No, the other method will be doing that.
The plus minus.
Yeah.
Yes! Let me, well, it's a little bit different, but let me show you it, okay? Can I scroll down now for the other method for this one?
Yeah.
Yep. So, 2 absolute x minus 1 less than or equal to 4. Now, the plus minus method is not as easy as you think here. Can you watch carefully? So, what we do is, we consider this problem in two halves. The first half is x minus 1 is a positive, or, if it's not a positive, then x minus 1 would be a negative. So let's consider this situation where x minus 1 is a positive. In other words, we know the answer is bigger than or equal to 1. Okay, this becomes a lot easier to solve. If I know this is a positive, do I need the absolute anymore? No, because I know it's a positive. So I get x minus 1 is less than or equal to 2. So x is less than or equal to 3. Yeah? But, remember we said this at the beginning. So we also need here x must be less than or equal to 3 and x must be bigger than or equal to 1 because we need this to be true. We said this is true at the start. Here, let's consider this is true. X minus 1 is a negative. So if I have this, what does the absolute do if this is a negative? Flips the sign, makes it positive. So we have 2 with a minus, x minus 1 is less than or equal to 4. So we get x minus 1
Why
bigger than or equal to 2.
Why negative
X
2?
is X.
Because this I know is
Is negative.
going to need a sign change because it's a negative.
Okay.
Oh my goodness. Absolute of minus 2 is the same as minus minus 2. So if I know it's a negative, I can drop the absolute and put in an extra minus.
Okay.
Right. So this means x should be bigger than or equal to 3 and x needs to be less than or equal to 1. And remember, between them is or. So this is an and this is an and this is an or. So how can x be less than or equal to 3 and bigger than or equal to 1? Well, if you draw that on the number line, there's 1, there's 3. It has to be between 1 and 3, obviously. And what about this? We need x to be less than 1 and more than 3. Doesn't work, so reject. So the answer is x must be between 1 and 3, which is the same answer we got a moment ago. But you're thinking, I don't like this.
Why reject it?
There's no way x can be bigger than 3 and less than 1 at the same time. There's no region on the number line that is both bigger than 3 and less than 1. There is a region that's less than 3 and bigger than 1, but there isn't a region that's bigger than 3 and less than 1. And forward. There we go. So you probably prefer the first method.
Yes.
Depends on the question.
It does, but for something like this, the first method is fine. Yeah. Okay. Another example now. Do you have this? What if you have double absolutes? Nothing really changes. Like for example, if you had absolute of x minus 1 equals twice the absolute of x plus 2, or something like that. You still can solve it by squaring. So if you square, you would get x squared minus 2x plus 1 must be equal to 4 times x squared plus 4x plus 4. So you get 4x squared plus 4x plus 4. No. 4x squared plus 16x plus 16 minus x squared plus 2x minus 1 equals 0. So you get 3x squared plus 18x plus 15 equals 0. And it's now just a quadratic to solve, which is perfectly normal here. Come on. I'm not that boring.
I'm only rolling. Whoa!
How can we leave this?
I'm so hungry. Right.
Too much energy.
Yeah, spread it around, would you?
Too much more.
It's simple. What is simple? Organically.
But it's, Yusuf, it's a very undirected energy.
Yes.
You know, it's energy, but it's unfocused. It's like
Everywhere.
a childlike energy. I need to be able to put them into one of those ball pits, you know?
Currently, it's different in Germany.
Faisal,
You know, the same song.
I need to put you in one of those ball pits, I think.
What?
You know those big pits full of little plastic balls for babies? Yes. I think this is what's needed.
I will have lots of fun.
Yeah, I know you will. Yeah. And then when the class is over, I can come back and collect you and it'll be great. Okay. Right. Some of these questions get very hard towards the end, especially these ones here. Although you might be surprised, they're not as hard as they look. Okay.
Throw your stress away.
No, I actually heard something hit the board.
Yeah, me too.
No, nothing.
Well, her stress is high if it actually takes physical form.
It was like,
Yeah. Class dismissed.
Love.
yeah.